Welcome to this video. For today, we will be talking about the formation of faults and folds. But before that, please watch these videos.
What are you doing?
Screams up my ass. Don't reminds me of
Hi, I hope you had a good laugh because for this part we will be talking about stress. Stress can be viewed in several contexts. In human, stress is the state where a person experiences pressure which can either make or break a personality of an individual. Similarly, stress in the context of geology is the force exerted to rocks which can cause rock deformation. Have you ever wondered what are the different processes which apply stress on rocks? How are folds and faults formed? The constant movement of tectonic plates continue to shape Earth's structure. When rocks are subjected to stress, it responds by flowing, bending, or breaking. Eventually, these events led to the folding and faulting of rocks. Types of stress. There are two general types of stress, confining stress and directed stress. Confining stress takes place when a rock or sediment is buried and acts uniformly in all directions. The pressure builds up as materials are piled above a certain layer of rock. On the other hand, directed stress only acts in one direction and is most likely associated with tectonic activities. There are three types of directed stress, namely tension, compression, and shear stress. Tensional stress. This causes rocks to be pulled apart, which fractures the layer of rock. It usually occurs at divergent boundary. Compressive stress squeezes and shortens the layer of rock. It usually happens at convergent boundary. Shear stress acts in parallel but opposite direction. This type of stress causes one rock to slide past another as seen in transform fault boundary. Stress produces the deformation known as strain. There are several factors which could influence rock deformation. The nature of the material affects how a rock behaves when stress is applied. Meanwhile, the higher the temperature, the more likely it is for the rocks to deform. Moreover, pressure also affects the behavior of the rocks under stress, wherein as pressure is added, then the more likely a given rock could be deformed. Lastly, stress applied over a long period of time in a slow yet constant manner could eventually lead to rock deformation. So I tried to search if I could get reference pictures about rock deformations and its types, but all I got are these overly complicated figures and we don't want that, so I animated small clips for us to easily understand this topic. There are three types of rock deformation: elastic, ductile, and brittle deformation. A rock undergoing elastic deformation goes back to its original size and shape once the stress is removed, which means that as the stress fades or is removed, it will go back to its form before the stress was placed. Ductile deformation, on the other hand, is a condition where it moves in plastic manner that could lead to permanent change in shape and size, yet do not involve breakage of rock. This deformation occurs at the area which has high pressure and high temperature. Brittle deformation occurs when rock surpass its elastic limit when stress is applied, thus leading to the formation of fractures. It occurs at low pressure and low temperature conditions. Ductile deformation is associated with folding of rocks. The series of wave-like ripples or bends formed during mountain building are called folds. Some folds are composed of several hundred of meters layers of rocks bent and deformed, while others are only present in a microscopic scale. In general, most folds are products of compressional stresses. Folds, general characteristics, and its parts. A fold is composed of various parts. A fold arching upward is called an anticline, while one arching downward is syncline. Limbs are the sides of the fold. The imaginary plane symmetrically separating the fold into two is called the axial plane. You can see here that these are the axes of anticline and syncline. These fold axes are the line dividing the fold into two limbs, and it passes through either the crest or the trough of the fold. Folds can be symmetrical or asymmetrical. Additionally, overfolds are folds that inclined in an overturned manner. Meanwhile, recumbent folds are those tilted beyond the vertical axis in which the folds are already parallel to the horizontal plane. On the other hand, if the fold has only one limb, it is categorized as a monocline. Folding of rocks could also result in other land formation. A circular or an elliptical anticlinal structure known as dome can also be formed. It usually looks like an inverted bowl. Basin is a synclinal structure which is the inverse of a dome. We can see from the figure the difference of a dome and a basin.
In geology, an upward arch anticline is used only if the oldest rocks are in the center and the youngest rocks are at the outside of the fold. Like for example, we have here a fold. So the oldest rocks can be seen here at the center, while the youngest rocks can be seen here at the outside of the fold. That is called the upward arch anticline. However, if the ages of the rocks are unknown, an upward arch form is called antiform, which is also similar to anticline. So this one here will be called antiform if the ages of the rocks of the fold are unknown. If we did not determine the ages of the rocks, this will be called antiform, which is also similar to anticline. Syncline is only used to describe downward arch fold when the youngest rock is located at the center. Otherwise, if the rock's ages are unidentified, the downward arch is termed as synform. So just like the antiform, if the oldest rocks are located outside the fold and the youngest rocks are located at the center of the fold, but we do not know the ages of the rocks, we call it synform.
Faults, general characteristics, and its parts. Some rocks eventually break or fracture in response to the stress, whereas this process involves brittle deformation. A fault is a fracture or a discernible displacement where rocks grind or slide past each other. Movements along a fault can be gradual or sudden and may create large magnitude earthquakes. It is also possible that a fault can be a single fracture in a rock or can be composed of a series of fractures called fault zones. Parts of faults. A fault line is the trace of fracture on rocks, while fault blocks are those that interact during faulting of rock layers, which can either be hanging wall or foot wall. The overlying side of the fault is called the hanging wall and is named as such because miners notice that it is usually the side that hung over their heads. The side beneath the fault and most of the time where the miners walked is called foot wall. Types of fault. There are several types of faults. A dip-slip fault involves the upward and downward of fault blocks which either be normal or reverse fault. A normal fault is where the hanging wall moves down relative to the foot wall. It is a product of tension which pulls Earth's crust apart. Graben is formed when a wedge-shaped block or rock drops downward between a pair of normal faults. Meanwhile, hoar is the uplifted block or rock situated between a pair of normal faults. In a reverse fault, the hanging wall moves up relative to the foot wall. It is a product of compression and therefore shortens the structure. A special type of reverse fault is known as the thrust fault that causes nearly horizontal movement due to its low angle of inclination, which is less than 45 degrees. A strike-slip fault occurs when the blocks of rocks move horizontally past each other. This is a product of shear stress and usually present in transform plate boundary. This can either be left strike-slip fault and right strike-slip fault depending on the direction of movement of a block of rock which reference to another block of rock. The oblique fault has both a dip-slip fault and strike-slip fault. This implies that it involves significant horizontal and vertical movements. Furthermore, there are also different fractures in rocks. Joint is also a fracture in a rock, but unlike faults, joints do not involve discernible displacements. One of its examples is the Jurassic limestone layer, which is found in southwestern England. Now, let us go back and review the very important key points about this topic. Stress is a force exerted on an object, in this case, a rock. The different types of stress includes confining stress and directed stress, which further subdivided into tensional, compressional, and shear stress. Rock deformation involves changes in shape and or size, which can either be permanent or temporary. The different types of rock deformation include elastic, brittle, and ductile deformation. Folds are series of wave-like ripples or bends which is mostly formed when rock layer is subjected to compressive stress. It is composed of upward fold known as anticline while downward fold as syncline. Fault is a fracture or a discernible displacement where rocks grind or slide past each other. These different types of faults includes normal dip-slip fault, reverse dip-slip fault, strike-slip fault, and oblique fault. Joint is also fractured in a rock, but unlike faults, joints do not produce discernible displacement.